Hello, physics. This is an interesting question about capacitors. The circuit is given that EMF and uh, internal resistance is a small r, and this is a switch, and this is resistor R capital, and this is a capacitor, and this is a circuit. The quantities are given. EMF is 6 volt. Internal resistance is a 0.3 kilovolt, kilo ohm. Resistor is a 2 kilo ohm. Capacitor is a 50 microfarad, 3 sig fig. Calculate the current flowing I naught through the circuit at t is equal to 0 when the switch is closed. Number 2, Kirchhoff rule describing the charging of the capacitor. Find the differential equation. Number 3 is solve the differential equation. 4, sketch the graph as a function of t. And final fifth question is the energy stored in the capacitor. At the t is equal to tau is time constant. So answer. So when switch is closed, T is equal to 0, Q at the charge is 0, and the voltage at capacitor is 0. So current flow through the circuit. So uh, EMF is equal to the internal resistance, I naught plus R I naught. So I naught is equal to small r plus capital R. So I is equal to EMF over R over small r over capital R. EMF is 6, small r is a zero point 0.3, and this is a 2 in 1000. And final answer is a 6 divided by 2300, which is equal to 2.61 into 10 power minus 3 ampere. So this is in 3 sig fig, or 2.61 milliamp. This is the answer of the current. Now the charging of the capacitor. So when charging the capacitor, EMF is equal to R into I is the current, plus R capital R into I, plus Q over C, which is the current into the capacitor. So I is the current, I is equal to dQ by dt. Rate of change of the flow of the charge is a current. So I is equal to R small plus capital plus Q over C. So EMF is equal to this value, dQ by dt, R plus a capital R or Q over C. So this dQ by dt differential equation, this is a form of this one. This is question number 2. So the differential equation dQ by dt is equal to EMF over R over plus R minus Q over R plus R into C. So this is the differential equation. Then we have to solve this equation. So solving this equation, so dQ by dt, which is written in this form. So in this form, dQ by dt. So dQ, we can take LCM, R plus R into C. So this is C EMF minus Q. So then take this one. This is the variable. This is the variable. So these are the two variable. So this is a dQ by CE, CEMF minus Q, and to dt by R plus capital R into C. That is a minus, so we have to take this one as a negative. So then take a negative this one, multiply this one. So minus dt R plus R into C. So now integration from 0 to Q charge in 0 to T time. So then this is equal to ln natural log of Q, Q plus CE, CMF, 0 to Q, and this one will be just a T. This is the constant, 0 to T. So when is Q is a Q value, when Q is a 0, this is will be only this one. So ln Q minus CE over minus CE, minus minus CE. So this will be minus CE into minus T by this one. So this will be the answer. Minus T, this one, minus plus. So minus plus, this will be, am I right? So this will be T and then will be 0. So T uh, and then R plus R into C. C into EMF is equal to Q charge, the total charge. So this term inside, yes, this will be negative. This will be correct. Q minus C EMF is minus CE, which is equal to Q minus Q naught over minus Q naught, or which is equal to this one, Q minus Q naught plus 1, or 1 minus Q over Q naught. That is correct. So we will substitute this value to ln 1 minus Q over Q capital, which is equal to minus T R plus R into C. So we have to find this expression. So this one is equal to, if you take off ln 1 minus Q over Q naught is equal to E raised power T, and this one all go to the exponential. So from here, this will go on this side, this will go on this side. So this will go in this side, Q over Q naught is equal to 1 minus E raised power exponential minus T over R plus R into C, which is equal to Q over Q naught, 1 minus E raised power T, E raised power minus T R plus R into C. This is the expression of the charging of the capacitor. So this value is 1 minus of exponential. So we will sketch the graph. So this will be equal to, this is the growth with the 1 minus this one. Otherwise, it is like this one. So energy stored is a time constant T is equal to R plus small r into C, RC. So energy is, there's few expressions, half a QV, or half a CV square, or half a Q square C. Q is given. So this is the expression of the Q. When T is equal to R plus small r into C, so this will be equal to e raised power minus 1. So Q will be equal to CE 1 minus e raised power minus 1. So substitute this value here. So this is equal to CE 1 minus e raised power minus 1 whole raised power 2 divided by C. So that will be square here and C. So half C square E square by C 1 minus e raised power minus 1 raised power whole square. So C half C E square 1 minus e raised power minus 1 whole square. So this is an expression, half C is a 50 microfarad. C is EMF is 6 volt, 6 square into e raised power minus e raised power minus 1 whole square, which will give us the value which is equal to 3.60 10 power minus 4 joule. So this is the final answer. And this is a very good question. This is the expression and this is the question.